So yesterday we talked about right triangle trigonometry. And when you have a right triangle, you should really verify that you have a right triangle. If they don't put the little 90-degree box in there, you can't assume it's 90 degrees. But you can use SOHCAHTOA if it has a 90-degree angle, or you can use the Pythagorean theorem. Those are the two things that you can use with a right triangle. Today we're going to look at what's called the law of sines, and this is when we don't have a right triangle. So, anytime, I tell students all the time, anytime you have two angles in a triangle, find the third one immediately, even if you're not going to use it in the problem. It might not be one of your answers that you need, but just find it. So, to find this missing angle, we can take our 180 minus, and you can add your 53 plus 29. What do we get?
98.
$98 degrees. So now you can definitely tell you don't have the right triangle. So we're not going to be able to do SOHCAHTOA. So that should be park, by the way, not park. Two park rangers and towers 10 miles apart in the national forest. So there's one over here at A. There's one over here at B. Spot a fire that is far away from both. Get a little yellow in there for the fire. Maybe a little orange, yeah. And then a little smoke plume coming out. So what they're saying is one ranger recognized that the fire location, he knows it's at a certain point that's 4.9 miles from his particular tower. With this information and the angles given, help the rangers calculate the distance from the fire and the other tower using only right triangle trig. Well, we can't. What's that? Well, we need to know what we send. So we need to be able to find this distance x. But you can't use right triangle trig. Okay? You can't. We don't have a right angle in this problem. So what we need is what's called the law of sines. So in the box, I'm going to write it a couple different ways. You can do the side over the sine of an angle equals the other side sine of another angle. Or maybe, I'll get out of the way in a second, sine of the angle over its side, sine of an angle over its side. What this is telling you is that you will pair them up. These are what you'll hear me call angle, side, they're angle side pairs, partners, I might call them, or we talked about the term opposite yesterday. So a good definition for when things are opposite each other is when they don't touch. So every angle touches two sides, right? So if you look at an angle, its partner side will be the one side it's not touching. So let's go back to this problem and take a look at it. If I want to find side x, what is its partner angle? It's touching 29 and it's touching 98. X touches those two angles. So the one angle it doesn't touch is 53. So we're going to write x over the sine of its partner angle. So you put those two in there. The second part, you can pick whatever you want. So I'm just going to use the 29. I'll stay with the same color. the 29 and the 4.9. Now, which one should go on top? If I have x on top written down first, what goes on top? The 4.9, because that's the side. X is representing a side in this case. Sine of 53 is the angle, so I'm going to do 4.9 on top over the sine of the 29. That's the law of sines. So every time you do the law of sines, there are 4 pieces of information, right? You have to know, obviously, 3 of those pieces. So it means you have to know an angle side pair, or an angle and a side that are opposite each other, and 1 more piece of information. Then you can do law of sines. So what do I have to do to solve that? How do I get x by itself? Do sine of 53. So if we go to the calculator, I can type in 4.9 divided by the sine of 29 degrees, was it?
Yep.
Of 29. So again, remember in mode, you want to make sure your calculator doesn't go back to radians. We want to be in degrees. So 4.9 divided by the sine of 29. That's the fraction over there, and then now we're multiplying by, what was it, the sine of 53? Thank you, sine of 53. And we get approximately 8.07. So about 8.07 miles. That is the basic law of sines. Law of sines never changes. Now, when I do every law of sines problem, I will put my variable in the top left corner. But that means sometimes I'm going to put my sides on top. Sometimes I'll put the angles on top, because we can use law of sines to find angles. If you guys are the type of student you want to write the same formula down every time, then you're going to have to use a cross multiplication, because now you have a fraction equal sign of fraction. So you can cross multiply and then divide by what you don't need. But be good at one of them and stick with it, whatever you're going to do. But the law of sines never changes. Never changes. So, when should we use the law of sines? Basically, what you guys are going to do, you have to know at least 1 angle side pair, and then I say plus 1. So in other words, you have to know 1 angle and side that are cross or opposite each other, and 1 more angle or 1 more side. Then you can use law of sines. Period. We're not going to get into, there are some weird things once in a while with ambiguous cases. We don't really get into it. We would not try to trick you with it, but that's when you should use it. Okay, suppose these 2 eagle-eyed rangers spot another fire in a different spot indicated on the diagram. Use what you know about the angles in the triangle and the law of sines to find the distances from each tower to the fire. So I would like you to find, remember this will be little b, and this will be little a. Big A, big B stand for the angles, little a, little b stand for sides. So before I can start this, do I have enough information in that triangle to do the law of sines? 135 matches up with what? A. So I don't know that angle side pair. 14 matches up with little b. I don't know that angle side pair. 10 miles goes with what?
C.
Angle C. Now, on the diagram, I don't know it. But mathematically, we know it, right? How do you find angle C?
Subtract
180 minus 135 plus 14. So what is angle C? 31 degrees. So let's write that in there. In this particular problem, we do need to write it in there. We need that. So if I was going to find little a is partnered with 135. So I write little a over the sine of 135. Then I know the third angle C and side C. That's the one that I know, so I'm putting that in there. I put the 10 on top and the sine of 31 on the bottom. Can somebody give me the answer for that? When you guys get to the test, I know you are using your calculator, right? And most of you probably can look at this one and say, do this on my calculator, multiply by the denominator. I don't need to see you solve it, but you have to write this down. Right? Make sense? Just write the formula or the equation down. What do we get for little a?
13.7.
13.7 approximately. Okay? Little b over sine of 14, right? This is one of those where I get, because it's an obtuse and this everything, you know, some of these angles open up, people have a hard time kind of looking at what's opposite b. But if you look, b touches 31, it touches 135. It does not touch 14. So b over the sine of 14. Now you could use side A and angle A. Why should I not use side A and angle A?
Because we rounded. We didn't use the exact number.
We rounded. Are you always 100% sure of your answers? I mean, maybe you made a mistake so it might not be correct. So always go back to the ones that are given. And in this case, I get it, 31 was not given, but I'm more confident that I got this right than this right. So we're gonna go back to 10 miles and sine of 31. So the partners that I know are used both times. What do you get for little b? 4.69. So let's keep them the same, we'll just round them up. Now, when you get done, a quick check is just to make sure that the big angle is opposite the big side, the small angle is opposite the small side. So when you put in 4.7, that would be over here, and 13.7 would be over there. Big angle, big side in blue, 14 and 4.7, it makes sense, right? Biggest angles and biggest sides always go together. Smallest angles, smallest sides always go together. All right, for number one, an airplane off course over the Atlantic Ocean was experiencing mechanical problems. The pilot sent 2 calls, one to Boston Logan International Airport and one to the regional airport in nearby Beverly. Air traffic controllers at the 2 airports reported the angles shown in the diagram below. How far was the plane from each airport? So the distance between the 2 airports is fixed at 25 kilometers. So what I want you to do with somebody sitting near you is find x. Now let's call this one y. So I want you to do the law of sines as fast as you can. Check your answers with somebody. I'll put the answers up here in a second.
I found X and Y.
So you did.
180 minus 81 plus 73. So I'm adding up the 2 angles, subtracting from 180. What's the missing angle?
26 degrees.
26 degrees. So that is the angle side pair that I know. So I'm going to use that both times. So to find x, I put that over the sine of 73, and then I do my 25 and 26. So 25 is the side on top over the sine of 26. Y goes over sine of 81, 25, and sine of 26. So you need to write those two down so I know what you're putting into the calculator. What do you get for x? 54.5 kilometers. Y?
56.3.
56.3. Are people agreeing with those two things?
Yep.
Okay. Okay, so we should put x on top over the sine of 80. 17 on top over the sine of 78. This is not an isosceles triangle, but because those two angles are so close, it's going to be very close to an isosceles, right? So an isosceles means if the two angles are the same, the two sides will be the same. So when I get done, I already know if 78 degrees is a length of 17, 80 degrees will be slightly more than 17, right? It's a little bigger angle, so it should have a little bigger partner side. So what do you get? I heard some people say 17.1. Are we getting that? Good. We can also use law of sines to find angles. So if you look at this diagram, (39 and 12) are the angle side pair that I know. They match up, they're opposite each other. So again, this is how I do my law of sines. I put that missing piece or the variable in the top left corner. So I'm missing an angle. So there are really two things you have to do here. One, we have to multiply by 5 on both sides. So my sine of x will equal all of that stuff. Then what's the last thing we have to do? What do we have to do to get rid of the sine? Sine to the -1 on both sides. So remember, x is going to be an angle, so here's what it looks like. On the right-hand side, I had the sine of 39. You have to close it. Anytime you put sine on top, you have to close it. That's why some students like to keep sine on the bottom, because if you do a side divided by the sine, you don't have to worry about closing it. But if you have it on top, you do. What were we dividing by? 12. So I would get that into my calculator first. That's a decimal. Then we're multiplying by the denominator of 5. It's also a decimal. This is good. That is not the angle. That's not the angle, right? Anytime you're looking for an angle, you have to hit second trig function, whatever trig function you work with, to get the angle. So second sine, and I would hit second negative. Second negative just pops the last answer in there. Then you're not worrying about rounding it or anything. The calculator just does the work, and it's about 15.2 degrees. So 15.2 degrees. So angles or sides with the law of sine. We have to be very careful using law of sines. I said this earlier. just because I have enough information to use law of sines doesn't mean it's always going to work. So we don't try to trick you with it. But if you can use, what's the triangle sum conjecture?
Where all angles have to add up to 180.
If I can use 180 minus the sum to get an angle, I'm going to use that. Also, we're going to use the law of cosines, which will be the next lecture, before I do the law of sines, because the law of sines sometimes can have some issues. I'm going to pause, and you guys are going to do some work, ask me any questions. We're going to finish these two problems, and then we'll put the answers up there. So you can work in groups. And the very first one for number 4, right now I have side 10, angle 110, so I can find x first. So if I do sine of x over at partner side 4, that's equal to sine of 110 over 10. Now this is one of those problems that we just got done talking about that you want to be very careful using law of sines because maybe you end up with the wrong answer. It can happen. But how many obtuse angles can a triangle have? 1. So if this one's already 110, the other two angles have to add up to 90, or 180 minus that one, so it'll have to be 70. But you can't have more than one obtuse angle. You'd be over 180 then. So if you do the work here, sine of 110 divided by 10, multiply by 4, inverse sine, what is x equal to?
22.08. I rounded up.
If you go to 2 decimal places, round it up to the 8, 2.08. If you had 2.07, close enough. Now, I don't have to find this angle. Like it's not required, but to finish the problem, we have to find it. So you have to do 180 minus 110 plus 22.08. So what is this angle? 47.92. Because that's the angle that partners up with y. So now we can do side y divided by the sine of 47.92, and that's equal to 10 over the sine of 110. What do we get for y? 7.89. So in that particular example, we've done a law of sines to find an angle. We've done law of sines to find the side. Number 5. What do we find first?
I don't know.
Which angle do I have to find first?
B.
I don't know y's partner. Y is partnered up with x, right? So I can't find y or x first. So I actually have to find angle B first, even though they're not asking for angle B. So I would have to do the sine of big B. Sine of angle B goes with 8. I know my 9 and 65. So I can go sine of 65 over 9. So on your calculator, take the sine of 65, close it, divide by 9, hit enter. Multiply by 8, hit enter. Hit second sign, second negative, what do we get? A about 53 okay, that's, I don't know, round up to 53.7 is fine. So 53.7. Add that to the 65, so what's 180 minus 65 plus 53.7? 61.3. So that goes in there for angle Y. So the last thing is to find X. So I put X over the sine of 61.3, and I'd go back to the 9 and the 65. So 9 on top, sine of 65 on the bottom. X turns out to be approximately 9 divided by the sine of 65, hit enter, multiply by the sine of 61.3, and you're getting 10.95. Are people getting numbers close to that?
Yep.
Okay.